Hi all, welcome to my course AZ-900 Microsoft Azure Fundamentals Certification course. AZ-900 certification consists of 6 domains with different weightages for each domain. Domain 1 consists of basic cloud concepts. In domain 2, we will understand Azure core services. In domain 3, we will understand Azure core solutions and management tools in Azure. In domain 4, we will learn general security and network security features in Azure. In domain 5, we will look into identity governance, privacy, and compliance features. In domain 6, we will understand Azure cost management and service level agreements. Domain 1, we will cover some of the basic cloud concepts. Domain 1, describe core cloud concepts. In this model, under core cloud concepts, we will cover the following topics. We will start with what is cloud computing, some of the cloud computing key terminologies, what is the differences between capital expenditure versus operational expenditure, which is also called as capex and opex. Next, we'll look at consumption based pricing model, shared responsibility model, what are different types of cloud service model, what are different types of cloud deployment models, and finally, we'll understand what is serverless computing. In this session, we're going to see about cloud computing concepts. Cloud computing has been part of information technology for more than 20 years. There are many reasons for moving your resources to cloud, but one of the primary benefit of moving resources to cloud is to reduce your IT burdens from your company. The cloud allows you to take advantage of cloud service providers, infrastructures, and investments. It makes it easier to maintain consistent access to your applications and data. Hosting your data and application in cloud is often more cost effective than investing in infrastructure and on-premise IT resources. We will start with what is cloud computing. As per NIST, National Institute of Standard Technologies, cloud computing is defined as on-demand delivery of IT services oriented with pay-as-you-go pricing model. All your services, the services includes compute servers, storage, databases, networking, applications, and other services. All these services is available in cloud readily. You can use these services oriented and only pay for the services you use. That is a simple definition of cloud computing. In simpler terms, you can define cloud computing as you're using some own resources and only paying for those resources you use. Another simple example of cloud computing is that in every house we get a electricity bill, right? We get a electricity bill for you need to pay it monthly EV bills. We only pay for the EB consumed by the customers. We don't manage your electricity grid or um, locations where electricity is generated. We just use the electricity, and based on the bill we pay it monthly based on consumption of your EB bill. So it is a simple example of cloud computing. To understand it better, we will look at benefits of cloud computing. Cloud computing provides on-demand delivery of IT services. All these services in cloud computing is really available, and it is a provides set pool of resources. All your resources of cloud computing is available in a single pool of resources, and it provides a broad network access. With cloud computing, you can access your services or resources from anywhere, any place, and from any locations across your globe. Cloud computing also provides you scalability of your resources based on your business needs and application demand. If there's a application demand or business needs to increase your resources or workloads, you can scale your resources uh, at any time within a minutes in cloud computing. It also reduces your infrastructure cost. In cloud computing, you just need to set up your physical data centers or manage or maintain your data centers All your data centers will be managed and maintained by a cloud service providers as the customers just utilize the services in cloud. You can also rapidly provision your resources in a minutes in cloud computing. Finally, one of the important benefit of cloud computing is pay-as-you-go pricing model. Pay-as-you-go pricing model means that you only pay for the services you use in cloud computing. If you don't use these services, you don't need to pay. The cloud computing key terms. Here we will look at some of the key terminology for cloud computing. We will start with high availability. The availability of your application and data is core requirement. If application or data or services is not available, then it may lead to a huge outages or loss of data or applications. You need to ensure that your application and data is always available in cloud. The cloud service provider makes sure that all your applications and data is highly available always. There are many reasons you may lose availabilities. Some of the common reasons for lack of availability are due to network outages, power outages, application failures, system outages, operating system failures, or it may also due to database errors. Scalability. The cloud scalability is used to increase the workload based on demand. It is static in nature and is mainly used for long term in your organization. For example, in your organization, you have a database with similar in size which is implemented earlier. As day passes, you need to increase your database size to meet your higher workloads demand. With cloud service provider, you can increase your computing resources. The scalability are of two types. Vertical scalability, which is also called a scale up, and horizontal scalability, which is also called a scale out. The vertical scalability is used to increase the computing resources such as CPU and RAM, whereas the horizontal scalability is used to add additional resources such as VM for increasing workloads. Elasticity. The cloud elasticity is used to meet a sudden up and down of your resources for a shorter period of time. The elasticity is used to meet the dynamic changes where resources can be increased or decreased. The elasticity reduces your infrastructure cost. Elasticity is mostly used by smaller companies to meet a sudden spike in the resource utilizations and is used only for short-term planning just to deal with the unexpected increase or decrease of resources. For example, you are running a shopping website. During any festive season, demand for the resources increases and you find sudden spike in the website. As many customers browse your web page, during a short period of time, it is required to increase your resources availability to meet your demand. Agility. Agility in the cloud is defined as the speed in which resources are rapidly provisioned and resources are added to cloud. For example, you are running two VMs for handling your workloads, but suddenly the spike for the resource utilization increases. Then you need to add additional resources to handle the workload. The cloud computing provides the speed in which you can add additional resources to computing services to handle the workloads. Disaster recovery. In case of outages, you need to ensure that data and applications are available for end users. You need to create a disaster recovery plan for applications to ensure that your application and data is always available even during any unnatural circumstances. The outages may occur due to natural disaster such as earthquake, storm, environmental or any other political situations. The disaster recovery is not only to back up your data from one region to another region, but also to replicate the applications and data so that if any outages happen, then the application services and data is always available to customers. CapEx versus OpEx, capital expenditure, which is also called as CapEx. CapEx is an upfront infrastructure cost spent on setting up your physical data centers and devices. Operational expenditure, which is also called as OpEx. The OpEx is a cost involved for organizational operational expenses and day-to-day business and services. Here are a few differences between CapEx versus OpEx. In CapEx, the asset purchased is for upfront infrastructure cost to meet your business requirement, whereas in OpEx, it is ongoing expenses to run your business. CapEx is a one-time purchase at beginning and you can use it till end of life. In OpEx, it is a flexible and only you pay as you need. In CapEx, you need to own and maintain the asset purchased, whereas in OpEx, the providers maintain assets while customers focus on the core functionality. Few examples of CapEx are buying or renting data centers, buying and maintaining hardwares, example servers, storage arrays, etc. Buying software license upfront. Example of OpEx are no need to worry about data centers, paying monthly for Azure services as consumed. Example, pay monthly for storage and compute based on your consumptions, subscribing for softwares and paying monthly based on consumptions. Consumption based pricing model. The consumption based pricing model is a cloud service that allows users to pay only for those services or resources you use or consume. In consumption based pricing model, there's no upfront cost. For example, in consumption based pricing model, if you have a virtual machines running your applications and these VMs is running storage and database servers. In consumption based pricing model, as a customer, you only pay for the resources used. Here it is database or storage services. You don't need to pay for the resources or services you don't use or consume. The consumption based model has many benefits. Some of the benefits include there's no upfront cost, no need to purchase and manage your infrastructure, the ability to pay for additional resources if and when they are needed, and you also have ability to stop paying for resources that are no longer needed. Shared responsibility model. In cloud, the security and responsibility is shared between customers and cloud service providers. The security of the cloud is responsibility of a cloud service provider, and security in the cloud is responsibility of the customers. The responsibilities of cloud service providers include all the underlying hardware infrastructures, data centers, regions, availability zones, compute servers, storage, databases, and networking components. Managing and maintaining your data centers and infrastructure components are responsibility of your cloud service providers. As a customer, you manage operating systems running on your hardware, identity and access management, encryptions, firewall configurations, and customer data. Cloud service model. We have three different types of cloud service model. They are infrastructure as a service, which is also called as IaaS, platform as a service, PaaS, software as a service, SaaS. Infrastructure as a service. In infrastructure as a service model, the cloud service providers manage your hardware and infrastructure components such as virtualizations, servers, storage, and networking. Whereas customers manage the operating systems, middleware, runtime, applications, and data. Next is platform as a service. In platform as a service model, the cloud service providers manage your underlying hardware infrastructures such as servers, virtualizations, storage, and networking. The cloud service provider also manages your operating systems, middleware, runtime component. As a customer, you manage only the application and data. Finally, we have a software as a service. In software as a service model, your entire infrastructure components such as servers, virtualization, storage, networking, operating systems, middleware, runtime, application, and data are managed and maintained by cloud service providers. The customers does not need to manage and maintain any software or applications. You just use the application services deployed and only pay for the services you consume. Cloud deployment model. We have three different types of cloud deployment models: public cloud, private cloud, and hybrid cloud. First, we'll look at what is public cloud. In public cloud, the hardware infrastructure and data centers are managed by cloud service providers. The customers utilize those resources over internet and pay only for what they use. In general, the public cloud is defined as you are using someone's data centers and resources over internet and paying only for those resources you use. The data centers and physical hardwares are managed and maintained by cloud service providers. The hardware provided by cloud service providers are shared among different customers or organizations. Few examples of public cloud providers are Microsoft Azure, Amazon Web Services, and Google Cloud. Next important cloud deployment model is private cloud. In private cloud, the cloud is managed and maintained by a single organization. You can set up your cloud in your organization data center and is solely responsible for your organizations. Entire hardware and infrastructure is used by single organizations. The private cloud provides more flexible control over cloud resources and more security. Example of private cloud providers are Azure Stack. Hybrid cloud. The hybrid cloud is a combination of public and private cloud. You can have some cloud services in public cloud while few services in private cloud. For example, you can use public cloud to publish your organization data or organization website. You can use private cloud to have organization data for security. Serverless computing. Serverless computing is a cloud services used by developers. Developers use to build your application faster without need to manage the underlying hardware infrastructures. Developers can deploy the application faster without need to worry about the underlying hardware infrastructures. It doesn't mean that there's no hardware to run your applications. There is a hardware available to run your applications, but these hardwares are managed and maintained by cloud service providers. As a developer, you just deploy and execute your application code. The cloud service providers manages the infrastructure for you, provision your resources, scale your resources, and deploy your application faster. Some of the benefit of serverless computing is no infrastructure management, dynamic scalability, faster time to market, and more efficient of resources. As a developer, you just can focus on deploying your application and focus on your business. In serverless computing, you only need to pay for the compute time you are running your code or applications, not for the resources. Some of the examples of serverless computing are AWS Lambda, Azure Functions, and Google Cloud Functions.